Hello, guys, and welcome to the first ever event with the machine learning team of the DSC of University of Melbourne. I'm Pratyush, and along with me, I have Pulkit and Sanjog, who are to introduce and host this event for today. Today, we'll be starting with the introduction of machine learning with some Numpy, Pandas, Matplotlib, and Seaborn, essentially the very basics of machine learning that is super vital and important to your machine learning or data science career per se. So with that, oops. All right, yeah. Just for starters, this is a weekly workshop that is to happen over 9 to 10 weeks. And an overview is just this. We'll start with data science basics. We'll go through regression models, and we'll play along with the famous Titanic data set, one that you see in so many Kaggle, one that is super important to Kaggle competitions. If you don't know what Kaggle is, completely fine. We'll introduce you to it. It's essentially a data scientist's best friend for any competition whatsoever. And after that, we will follow with some trees, optimization, and an amazing capstone project. I have no idea why the slides are changing, but let's hope it's fine. Yeah, sure. So what we're going to cover today is Jupyter Hub installation, Numpy and Pandas, Matplotlib and Seaborn. If you don't know what these terms are, completely fine. We will make sure you know them by heart at the end of this workshop. So to start off with, I'm going to hand it over to Pulkit to introduce Jupyter Hub. Pulkit, do you want me to share screen?
Yeah, that'll be good, I guess. Great. All right, guys. Hey guys, I'm Pulkit, and I'm going to talk about the environment we're going to work for the next few weeks in, and it is really essential for you guys to understand Jupyter because it is an amazing tool used for various purposes such as machine learning. Jupyter Notebook is an open source web application that allows you to create and share documents that contain live code, equations, visualizations, and narrative text. The uses include data cleaning, transformation. You're going to learn about this later, but I'll just tell you the uses, because it sounds cool. Numerical simulation, statistical modeling, and much more. For data scientists, this is the best thing to learn. All right. It has interactive notebooks. You guys don't. There might be a chance that you guys don't know what notebooks are, but we're going to explain it to you. It can be implemented as a web app. If you're doing subjects like elements of data processing, they create a local server and which you can work on, and other people can also see your live code. It also supports many languages, over 40 plus languages. So you don't really need any other IDE if you have Jupyter. But we're going to work on Python. So now I'm going to start with the installation guide. Wait. Give me one sec. Okay. So as you guys can see, you just go. If you have Jupyter downloaded, I still highly recommend you to see it. After 10 minutes, we're gonna start with Pandas anyway. So you guys go ahead on the link in the chat. I'll just send it on the chat and just visit this link. We're gonna download Anaconda because Anaconda has Jupyter Hub and Jupyter Notebooks pre-installed, and you don't have to go through the libraries alone. So it makes it really easy for you guys to access Jupyter Hub. So I'm just going to click on download. Since I have it downloaded, but I'll just, yeah. Whichever OS you're comfortable with, just download the first link for that, and you're good to go. It's a open source software, so it doesn't really take anything. I have it downloaded, so I'll just cancel it. It's gonna take some time because it's 500 MB. So I'll just share what Anaconda Navigator looks like. Wait, give me one sec. it's starting. So it takes a bit of time to actually boot up Anaconda. But Anaconda is a great tool for machine learning enthusiasts like us. Yeah, okay, so Anaconda looks like this. And can you guys see it?
Yeah.
Okay, cool. So Jupyter Lab is like, is what we're going to work on. And if you want like a single Jupyter notebook, then you can go ahead on this. But if you want to like store your files, and I mean, you can still store your files on a Jupyter notebook as well. But if you want to sort your files in a manner like in a separate folder, then you should use Jupyter Lab. Also, it has many other tools like RStudio and VS Code, but you can download them and work on that. But for this workshop, we're just going to focus on Jupyter Lab. Just press launch and it opens your Chrome browser with a local host URL. Okay, so to make a new notebook, you just go on File and then New and then Notebook, and you select the kernel, which is Python for us, and you just go ahead with anything you want. Like you can work on anything. If you want to print anything, this is the best thing because like it has, wait, shit. Right, how can I be this stupid? But it's okay. Okay, the best thing about notebooks is like it has different lines and you can run like your different code with it, and you don't have to go through the hassle of like typing in commands again and again, and you can just run it by clicking the play button, and that's a really useful tool. Also, you can do visualizations here that we're going to show you with Seaborn a little while later. But okay, just like one more thing, like if you want to really create a file, because it's a really big file, you can just go to File and then New and then Text File. Just write whatever code you want to print, and then you can like rename the file as abc1 dot anything, like, but just with a .py .py thing, and then just go to terminal and just type Python abc1.py and it runs. Wait, it doesn't run because you're not in the directory. I made this file in the DSC week 4 directory. So to change your directory, you use cd and then you go DSC week 4 and then you're in the directory. Now you can actually run the file. But if you have like 2 folders in it, then you have to change your directory till you get inside the folder where the file is. Okay, what else? The thing with, do you see this icon? This icon states that the file has not been saved yet. That's why it's not printing hello. If I just press Command and S, the file saves, and it says here that saving completed, and now you can run that. You can see that now there's no icon like that, and if I print now, it says hello. It's a really good tool for basically every language there is. And now I think Pratish, you can take over.
Sure. Thanks, Pulkit. So just a couple of things to clarify before I start blathering all that I do. Just that, so while going through this, feel free to talk over me if you have any questions. If not, if you're comfortable posting a question in the chat, please do so. 3 of us plus Zach, our DSC lead, is here to help you throughout the way. If at any point it is not making sense, please let me know, and I will do my best, and the team will do their best to try and make it as easy as possible for you to understand, because this is really important for every single one of you to learn and understand before we move on to anything that is slightly more complex than this. With that, I will share screen. And right, so now that Pulkit's done, we will go to the next part of this workshop, which is NumPy and Pandas. So NumPy, we hope all of you know a bit of Python. If you don't, we will try to make that as easy as possible for you guys. But NumPy is essentially a linear algebra library in Python, which uses matrices, vectors, plots, and anything essential to the linear algebra space, vector spaces. Sorry? Oh, never mind. Yeah, so anything to do with linear algebra, NumPy is your library to go. Everything in data science is built on top of NumPy, and so it is very important to understand. So with that, I will start sharing my screen. Yep, I think I've mentioned this. I will start sharing the code part of my screen. Just give me 1 second. And yep. So the way we're going to take this workshop forward is that we don't expect you to, but we'd prefer if you follow along the way we are coding. Just have a split screen. On one side, you see us coding, and on another, you're doing it yourself. Because once you actually code, or once you get the experience of coding, you will really understand what's going on in the background, and you will be better equipped to implement whatever you are trying to learn. So the first and foremost step to anything in data science is importing your libraries. So I'm going to import NumPy as NP, and NP is standard notation done in every single industry, by every single data scientist really. Import NumPy as NP, and the first thing we're going to learn is how do we use something like a NumPy array. So a NumPy array is the most basic thing in NumPy, and it's essentially a 1D vector or a 1D matrix, right? And so if I have my list, so as you can see, I have a list over here, and if I were to convert it into a NumPy array, I just do array np.array, and I pass in my list, right? And once I output array, really simple. I have an array of 1, 2, 3, 4. Now, how do I know it's a NumPy array? It's because of this notation. This is often a visual indicator of telling somebody like us that, hey, listen, you have a NumPy array you're working with. And now that you do have one, you have a whole bunch of operations that you could explore and work on with this. Before that, I'll show you how to simply convert a 2D array into a NumPy matrix. And that is just, I'm going to have a list of lists. And again, I can just pass this to my NumPy array. And voila, the amazing work that we've done so far is we've converted a 1D matrix into a NumPy array. We've converted 2D matrix into a NumPy array, or a NumPy matrix, really. The way to know, so as we go through in data science problems, especially big data problems, one way to always find out how many dimensions your matrix is just by counting the number of brackets before. This is just a very small indicator, but really important. especially if you come to convex shapes and higher dimensional modules, where you really need to know what you're working with and how it really works, right? So with that, I will introduce some NumPy methods that really help just NumPy methods, same like that of lists or strings, that really help you to do some basic operations related to NumPy. So first off, we have the NumPy arange, which is very similar to your range method or your range function. All it does is return a range between your start value and your end value, excluding your end value, of course. And again, like I said, very similar to range. The difference is the range is a generator function. If you don't know what that is, a generator function is, yes, this. So a generator function doesn't exactly give you the output, or doesn't exactly give you every single value in that function. Rather, it just gives you it gives you a function where unless you actually call something like a for loop in that function, it doesn't give you the next value, right? It's super important to understand, because in Python always tries to save as much time as possible. And so a generator function only gives you the next value when you require it. So if I have a for loop and I do for I in range 0 to 10, for every time it hits that range function again, it then gets the next value. And until then, the range function isn't executed. But a NumPy arange, it gives you everything from start to stop, and that is what you essentially need to work with, right? If you want to do any sort of data manipulation. The next, by the way, am I going too fast, or are you guys able to catch along?
I think it's okay.
Sure, I'll just keep going on. Hopefully you guys, if any issues, just let me know in the chat. So just like so NumPy is essentially linear algebra for math, right? Linear algebra for computer science, right? And so one important package that we use for linear algebra is Matlab. And Matlab has some functions like zeros, which you also have in NumPy. You just, oh. Sorry, guys. Oops, my mistake. Something's going on here that's not supposed to happen. Oh, never. Sorry, guys. I gave a 0 by 0 matrix and expected something to happen. All right, yeah. So np.zeros is essentially a matrix full of zeros, and np.ones is a matrix full of ones. Now, it's super helpful especially when you're doing matrix multiplication, and matrices especially are really, really, really important when it comes to neural networks, because you're always multiplying one matrix by another. You're multiplying a weight matrix of weights, you're multiplying a matrix of biases. If you don't understand these terms, completely fine, but it's just matrix multiplication in the end. So you have things like zeros or ones, which are essentially a matrix full of whatever you specify in your tuple as an argument. And then you have your identity matrix, and there's always one argument for the identity matrix, because it's always a square matrix, right? After that, we have numpy.linspace. So linspace is like range, except you specify a start value, a stop value, and the number of evenly spaced elements you want in between. So from 0 to 10, I want 5 evenly spaced values, and that is why I have 0, 2.5, 5, 7.5, and 10. Again, you might not be using all of these just yet, but it's super important to keep in the back of your head, because as we go forward with this, it will be really, really helpful. Now, another important, very important, in fact, method that you use is np.random, and in the .random attribute, you have various functions like randint, exponential, binomial, logarithmic. So what np.random does is it gives you random values straight as. So np.rand just np.rand gives you a uniform distribution from 0 to 1, and any values that you want, right? So if I give 5 as my argument, I get a vector with a uniform distribution from 0 to 1 of all random values. If I do the same thing, but with 2 arguments, I get a matrix, a 5 by 5 matrix with all, again, a uniform distribution from 0 to n. np.random.randn, similar method, but instead of a uniform distribution, it gives you a Gaussian distribution. Again, the terminology might just go over your head, but that's completely fine. Just keep this in the back of your head, and trust me, it will be really helpful as we go along. And finally, with that, we have np.randint. So randint is again similar to Linspace, but it gives you 5 random variables from your start to your end value, excluding your end value, of course. Gives you a set of random numbers, and again, really helpful, especially if you're trying some data manipulation or just testing data in general. After that, we are going to learn something called shape. All right. So I'm going to save this as an array, as a variable. And when I do something like mat.shape, the attribute, it gives me 5, 5, which is essentially what it's trying to say is this is a matrix of 5 into 5, right? Now this is a very small, this might be quite silly because you're entering a 5 by 5 matrix, but where it's actually helpful is those problems where you have image recognition. You always input an image of 180 by 180 times 3, and times 3 is because you're finding the R component, G component, and B component of that. So you have a 180 times 180 times 3 image that you're always giving in the model, and models really don't understand 3D images. And so what you always do in that case is you reshape it. So I can do a mat reshape to a one-dimensional array. So if you see here, mat itself is a two-dimensional array, right, with 2 brackets, but now it's a one-dimensional array with the same exact thing. And this, in a way, is called one-hot encoding. This is a terminology used in data science, which is essentially to reshape it into a one-dimensional array. So now it becomes much easier if you just pass that entire one-dimensional array into the model, because then the model finds patterns in parts of that, especially if you're looking for a dog, to look for a dog or a cat and actually to classify that image, you find certain patterns in that one-dimensional array. And what the model does is recognize those patterns, so that if you put in another image, it would look for that pattern, see how much it matches that pattern, and then give you the result saying this image is a dog by the probability of 0.9 or 0.95. All right, so
sorry, let me just interject for a second. They want you to explain Linspace once more.
Oh, yeah, sure. So Linspace, it is similar to that of range. So you have 3 arguments: a start, stop, and the number of elements you want to have in between, right? And what Linspace does is that it returns those many number of elements that are equally spaced from each other, right? So in this case, I have all my elements. Why did I say elephants? Sorry. All my elements are with a difference of 2.5, right? So 0 to 2.5, 2.5 to 5, a difference of 2.5. And what it's trying to do is get equally spaced number of elements from your start to your stop value, and this is inclusive of your stop value. Again, the same thing would be if I want evenly spaced elements from 0 to 20, and I want 5 of them. I have 0, 5, 10, 15, 20, and all of them evenly spaced, of course. And yeah, does that make sense? I hope it does. If it doesn't, let me know, and I will try to explain it in a different way if I can. All right, so with that, we have a couple more interesting attributes before we finish off NumPy. And one of them is, let me see if this works. Right, mat.dtype. So .dtype, really important. It gives you information about the data, right? Now it's fairly obvious because I did mat.random.randn, and it's giving me numbers from 0 to 1, and that's a float 64. But when you're handling amounts of data which is completely unknown to you, just given in a CSV file, you will have to find out what your data is like. And actually, you need to know what your data is like before you manipulate it, right? And so it's really important to know what your data is. And to find out what your data is, you just do a .dtype after your data, and it gives you back your data type, right?
Let me just interject again. They want you to explain what reshape is.
.reshape, yeah, sure. So before that, I will just briefly do shape because .reshape is related to .shape. So .shape is giving you the shape of your matrix. If it's a 2-dimensional matrix, it's going to give you 2 dimensions, which is 5 into 5 in this case. If it's a 1-dimensional matrix, it should give you just 5. Like, for example, I have a 1-dimensional, a 1D array or a vector, really. I'm going to store this in a variable. And when I try to access the vector shape, I get 5, right? And vector by itself is a 1D array, right? So similarly, matrix, which I initialized over here, matrix is a 2-dimensional 5 by 5 array, and dot shape gives you the dimensions and the size of the dimensions. Dot reshape, what it does is that it changes it essentially changes one dimension of a matrix into another one. In this case, I have a 5 into 5 matrix, which is a 2-dimensional matrix with 25 elements, and I want to shape it into a 1-dimensional matrix. So all it does is it removes that second dimension and transforms everything into one single vector of 1 dimension, right? Now, it's important to keep in mind that the dimensions or the numbers should match. That is, if I had something like .reshape 23, that wouldn't work because I have 25 values, but you're trying to reshape it into 23 values, which really doesn't make sense, right? So you should always keep your numbers in mind. And a good way to do this is .reshape and multiply the values or multiply the shape that you know before, if you are converting it into a 1-dimensional array. Hope that makes sense. All right, moving on. Another important part about NumPy arrays is broadcasting. Now, broadcasting goes something like this. So I'm going to take the variable vector, and vector all is equal to 100. Now, if I see what vector really is, it's an array of 100. Now, before, vector was just this, right? It was a uniform distribution between 0 to 1 with all random variables, and all of a sudden, it's now all hundreds, right? Because that's broadcasting, and that's broadcasting of the equal to sign. Now, if I do something like vector into 2, it multiplies every single element of that and returns an array. It returns an array with everything multiplied with that specific vector. That specific scalar. I can multiply two vectors itself, And I get something again where every element is multiplied to the other one, right? Similarly for the subtraction, division, um, and in fact, what is even more interesting is something like, all right, I'm just going to get a uniform distribution again. So as you can see, V, random numbers between 0 and 1. And if I use the relational operator in this case, and I say all those elements lesser than 0.7, it returns me those values. It returns true with those values where it is actually below 0.7 and false for the rest of them, right? It returns me an array full of Boolean values. And that's really important is for pandas and NumPy, because if I do this, which is I'm asking for those values that are less than 0.7, it returns those values which are less than 0.7. And this is very important because, of course, this is a shorthand form or a shorthand condition that is very easily accessible in NumPy. You don't have to write an extensive function. Instead, all you could write is all you could put is one simple relational operator or one single um, addition operator or multiplication operator, and everything works so simply in NumPy, right? If you want me to show this to you again, you could do it with something like V greater than 0.7. It returns only those values that are actually greater than 0.7. And those are the values that you could use to, again, manipulate some more data or find some more insight to this. And with that, then there are some other useful NumPy arrays. This is just to keep in the back of your mind. You don't really use it that much, but most of it can be found in the NumPy documentation. np.sign gives you a sign function of all the variables in V. np.log gives you, again, logarithmic values for all values in vector V. And then you have np.exponential, you have np.cause, you have a lot of it. And all of it will be available in, all of it has to be available in the NumPy documentation. And I think Pulkit or Sanjo, you can post the link to NumPy documentation in the chat. And hopefully you guys understand. Yeah, hopefully you guys take a look and you'll really understand what I mean by literally everything's available. Any mathematical operation you could think of, it possibly is there. If it isn't, then you could make a function with aggregate of every single function that is available in NumPy documentation. So to review, what we did in NumPy is we started off by converting everything into arrays. You take a simple list, you just do np.array and pass in that list. For a matrix, you take a list of lists. It doesn't have to be, you know, a square matrix. It doesn't have to be, what's that? It can be literally anything. You pass it into np.array, and all of a sudden it gives you a NumPy array. We explored the arange function, which is similar to that of range. It gives you a value between your start and stop. np.0, np.1s, and np.i. Super important matrix methods. np.linspace. It returns an array with equally spaced values, the number of values that you want, especially. If I do 4, then I'll get 4 equally spaced values between 0 to 1. Sorry, 0 to whatever your end value is. Then np.random and np.randn returns random variables. np.random returns random integers, and .reshape is it gives you the shape, right? I don't think there's much of a description to that apart from the words itself. And finally, broadcasting, which is any mathematical operator or relational operator works with NumPy arrays and works really well. I think it works like a charm. So with that, I think you guys should know just enough NumPy to move on to the next thing in our lecture, which is Pandas. So again, like NumPy, wait, are there any questions with anything regards to NumPy before I move on? All right, seeing none, I will move on to Pandas. Yeah, I think, yeah, throw in the questions. If these guys can't answer, just stop me in my way and I'll do my best. But if these guys can't answer, I can't guarantee I'd answer that. But anyway, so with that, we will move on to something called Pandas. Now, like I said, Pandas, so everything is built on NumPy, right? And Pandas is exactly the same. So Pandas is essentially SQL, but built on NumPy arrays, right? And so the first step to it, of course, is import Pandas as PD. Again, very standard in the data science community. NumPy is MP, Pandas as PD, TensorFlow is TF, and Seaborn as SNS, Matplotlib.pyplot as PLT. Again, if it goes over your head, completely fine. We will go through everything together. So import Pandas as PD. And the first thing you do is something called a Panda series, all right? I'm going to use vectors equal to NumPy. So I have a set of random numbers from 0 to 10, and I'm going to convert that into something called a Panda series. So I do pd.series, and I pass this NumPy array. And all of a sudden, I have the same NumPy array, but instead I have indexes with that, right? Starting from 0, 0, 1, 2, 3, 4. And so if I were to store this as a series is equal to pd.series, and were to access that, of course, I get the same thing, right? Now, it's what makes it really helpful is the indexing, right? Indexing is literally the start to any database system. You want to access the entire row, or you want to access certain columns or certain features of that database, you do it by an index, right? You call it by the row or you call it by the column. Either way, you're trying to access some data, and it's really helpful to have, think of it as a hash table, right? It's really simple to have keys that point to certain values. In this case, you have an index. So a series has an index, and I could do it in a couple of different ways. All right. So I'm just going to show you a couple of different ways where I can convert data into a Panda series.
Pratt, will you be like showing the difference in performance when you compare NumPy and?
Oh yeah, thank you for reminding me. Oh man, completely forgot about that. Yeah, so the reason I keep saying NumPy is super important, and the reason I keep boring you with that same line is because of this. So np.random.rand 1000, 1000 is just 1000 by 1000 matrix, right? It has 100,000, no, a million values, and all I'm going to do is multiply those values. I don't need to store it anywhere. I just multiply it, and in NumPy you have something called the dot, all right, the dot function, which is essentially matrix multiplication for any two matrices. It takes one matrix, multiplies it with another. Now, if I were to run this again, nice, I get an error, and that's because I haven't imported NumPy. But if I were to run it again, so what I'm essentially trying to illustrate is that the power of two for loops versus the power of the dot function. Two for loops takes 6.2 seconds, but the NumPy dot method takes 0.12 seconds. And that is very, very, very important, right? because this is almost what 60 times the 60 times the latter, and that's important because you're going to be dealing with a huge amount of data, which is 140 rows or maybe 30 columns with that, and a lot of data points. And it's really important to parse that data and multiply matrices, especially when it comes to neural networks. And so having that speed is really important, right? With the same computing power, I have much better speeds. So of course, you would value this a lot more than you value just simple for loops. So with that, I will move back to Pandas, right? All right, so I have my list. I have a list of strings, a list of integers. I have a dictionary, and then I have a vector. I've already declared my vector just before, so I don't think I need to declare it again, but just for your reference. So I have these three values, and what I'm going to do is I will convert them into Pandas series, right? And a series is essentially a NumPy array, but with indexing. And so I do pandas.series my list, and I have my list, but indexed pretty well, right? Of course, it makes no sense to index 0 to 1, 1 to 2, but this is just an example with any random list, right? And so if I do pandas series, labels, I have ABC and indexed with 0, 1, 2. Now, just keep in mind that it automatically gives you a data type because it wants you to know what you're working on. And so the data type for the previous one, of course, was int64. The data type for the new one is not string, but it's called object in pandas, right? Because even those series with strings and integers in the same label, in the same series, which is, let's set if you have a mix of strings and integers, or if you just have strings, all of them are considered object, because in the end, it tries to encapsulate as much data as possible. In a series isn't just one data type. It tells you what you're working on, but it's always useful to know what data type you are working on before you manipulate that data, right? The other method is to convert a dictionary into a Pandas series. And what happens in that case, nice, is I get an error for reasons unknown. Oh man, God, I'm so stupid. Sorry, guys. So I have a dictionary with A is 1, B is 2, C is 3. I forgot to put in key values, but hope you guys don't forget that, right? And so now in my dictionary, all my keys have become my index and all my values have become my values, right? Again, Pandas series can take lists, dictionaries, tuples, but in a very weird way, not really necessary, and can convert it into a series. Now, if you might not think of this as helpful just yet, but so just 1 second. I'm going through my notes to see if I missed anything, and it looks like I have. Yes, sorry. And with that, we also have something called columns, right? I'm just going to do columns is just a list of values, and this same Pandas series, I'm going to pass in an argument columns as oops. Oh wait. Yeah, So weird. All right, guys, I think this is not important as of now, so I'm just going to skip it. Also because I can't be bothered to find the error as of now. Anyway, moving on. What is really important about the series is not the series. What is really important about Pandas is not series, but actually the data frame, right? And let me show you what a data frame is. So I have Pandas data frame, and I'm going to pass in something like labels, right? And now you have a very clean representation of essentially your series, but with a lot more values, right? Sorry, with a lot more cleanliness, and you have a column header over here as well. So a Pandas data frame is essentially an SQL table or a table by itself, where you have your columns on top, and you have your columns on tops, and you have your index to the side, and of course you can access your values with row and column pairs. Now for this, I'm going to import a data set. So sal is equal to pd.readCSV. Now so the Pandas library has a lot of methods, of course. One of them is read CSV, another is read SQL, you have read JSON, super simple, super easy to use. And if I just do something called sal.head, now, let me zoom out a bit. So as you can see here, this is a data frame from a CSV file. And what's really helpful is this, which is you have your column names on top, which is your employee name, ID name. So essentially this data frame that I have is a list of employee salaries and information about that and how you could possibly manipulate that data. It's not necessarily a data where we can find some insight because I just found it off the internet, but I think it's quite useful just to show you guys what's important and what's not. So in this, we have our columns, of course, you can see on the top, and we have our index. Now with the index, we have the employee ID. They're almost the same. Oftentimes you don't get employee IDs like this, and doesn't matter, whatever it is. So if I were to access values in this, I would do something like sal dot so if I was to access something like in a specific column, I would do sal employee name. So it is pretty similar to accessing or indexing records, right? So sorry, it is pretty similar to accessing lists, right? And so in your list, if you have something like bracket 0, brackets 1, or whatever it is, in this case, I'm going with column name first, right? I call the column name and it returns the entire column, which is fantastic. Now, if I want a specific row in that column, I simply do this like a 2D matrix, which is sal employee name and then the first element in that particular row, and I get this Nathaniel Ford, right? This is the most easiest way of accessing this. Another way to access this is the comma format, which is employee name, comma 0, which isn't supposed to happen again. Quite weird. All right, I will sort this out in a bit and I will tell you guys later. But either way, the important information to know is this is almost similar to that of a 2D array. And so what you do is you essentially call it with 2 dimensions, right? Oh, wait, yeah, sorry. Now I know what my mistake was. You pass this as a list by itself. Okay, I still don't know what my error is, but that's fine because I'm going to ignore it for now. Wait, now I know what my error is. Oops. Sorry about that, guys. So if I were to access, sorry.
No, go ahead.
Yeah, so if I were to access multiple columns, I just have to pass in a list of lists, right? In this case, I can pass in employee name, I can pass in job title, and just like that, I have 2 columns. If I want more, I just add in more. So another way to do this is accessing it by index numbers, right? So the first way that I taught you was this, just matrix format. The second way to do this is .loc or .location. And what that does is I call .loc with my column name. I'm going to use employee name in this. What is going on? I have no idea what's happening.
Just try iloc.
iloc, it starts with rows or columns?
It starts with rows only.
Yeah, sorry. So .loc is .location. All right, guys. So the best thing to do if you're stuck in a situation like this is, of course, find it in the documentation, right? Because I'm not getting anything. I'm kind of stuck in this situation. What I do is I would just Google pandas loc. Oops. I would go to the documentation. I would find out where I'm going wrong, and I'd slap myself in the face because I'm going wrong at a place where I'm not supposed to be going wrong. So .loc, and so as you can see, it always gives you examples. One thing is in this data frame, there's they've called a data frame. They've given it some values 1, 2, 4, 5, 7, 8. And as for index, Cobra, Viper, Sidewinder, which you can see, is your index, and columns, which I was missing last time, is your max speed and your shield, right? So to call .loc, all I have to do is pass in the column, the index name in the brackets, right? And so if I were to go back, our indexes are numbered rather than named. And so all I do is sal.loc, and I'd pass in the index that is the numerical value at that certain index that I'd want. Now, in some data frames, it's pretty important to know that your indexes can also be words, which is really helpful because Pandas allows you to change literally anything in your data frame to make it helpful for you. .iloc is, as of now, it's the same thing as .loc, but what .iloc does is that it converts every single row into an integer value. And so if you were to access the 0th element, it would ask you to access the first value from this data frame, right? .loc, .iloc, again, super important, really helpful in the Pandas data frame side of things. Another useful set of operations similar to NumPy is broadcasting, right? So if I were to do something like Sal, let's take overtime pay. Ooh, somebody got paid 245,000. I like that. Anyway, Sal overtime pay 200,000, right? I'm trying to find all those values that are greater than 200,000. Interesting. Oh, yeah, of course. So if I were to try to find all those values in overtime pay that are greater than 200,000, I would call that value. I would set it greater than 200,000. Let's do it without the sal outside because I'll start with that a little later. So I call that column with all those values that are greater than 200,000. I do shift enter, and like NumPy, it would send me those values that are, of course, it would send me an entire column with those values that are true or false, right? It sends me an entire Panda series of Boolean values. Now, if I want the exact values of those that are presented in these series, I would just pass sal around this, right? I would just pass the entire data frame where those values are true or false, and then it applies those false or true Boolean values to those specific statements or to those specific rows. And so, as you can see, in this entire data frame, there's only 2 people whose salaries are greater than 200,000. Sorry, whose overtime pay is greater than 200,000. And that's because in the Panda series, when I did greater than 200,000, it returned a Boolean series with all those values that are actually greater than 200,000. And all I have to do is wrap that around my sal, and this would apply this to my entire data set and return those values which are true in this previous series. So like that, I can set it maybe less than 10,000 to see if anybody's being paid less. Oh yeah, in overtime pay, a lot of people might just have 0 values, and that's completely fine. Again, broadcasting applies it to every single element. And in this case, again, it returns a data frame, right? It returns an entire data frame with certain set of values that are true based on this condition. And so even on this, I can look for the, .iloc. So I can look for the 0th element. Like strings, I can look for up till the 5th element, and I get 5 elements. I could look for the last 10 elements, right? And I do -10. And it gives me all values until the final, like excluding the final 10 elements. I can get the 10th last element, which is this, and so on. So really helpful because I've practically reduced an entire function in Pandas to something that is super short, to something that is 1 line. And that is really helpful. And that is really fast, especially in Pandas. And Pandas is what we are going to be using for any data science problem. You read something in Pandas, you understand it as a series, and you manipulate your data based on that. Another few commands that are quite important in a Pandas data frame, apart from some broadcasting and iloc and lock, which is .reset index. If I do this, it just essentially resets my index to 0, 1, 2, 3. Again, not super helpful in this scenario because my index was already 0, 1, 2, 3, but it returns a new column with that specific value. It returns a new column with the previous index, so you don't lose data in a Panda series. Now, I could also do something like adding 2 columns in a Panda series. I'm going to call this some column is my data frame, which is sal, and I'm looking for the specific column base pay plus sal overtime pay, right? And if I just output call, I get 148,000 rows, which is the size of this Panda series, and I get an addition of both base pay and overtime pay. And if I wanted to add this column into my new series, I would just call it like a dictionary, as if it already existed. Sal new column, and I'm going to add it to the previous column over here. I'm going to add it as a value to the previous column. And all of a sudden, when I call sal, I have a new column with all added values from what I just did in the previous statement, right? Now this sal.head, .head is a function that returns only the first 5 values as default. I can just pass in 3 and it returns only the first 3 values. It's really helpful because you don't want to keep saying 148,000 values every single time, especially if you have changes in the column. You just, who is that who did it? Anyway, it's super helpful to do dot head because it's super important. It's super helpful to do dot head because if you want to see changes only in the column or changes in certain rows of this data frame, it returns only those values that you want from the start, right? If I do a dot head 3, it returns the first 3 values. If I do a dot head 5, it returns the first 5 values. So in this case, I just did a dot head 3, and all of a sudden I see the first 3 values, and I see my new column added to it, which is fantastic. Now somebody was pointing out to this, which is NaN. This I was planning to get on later, but now that you guys have mentioned it, it would be really helpful to look and understand. So NaN is similar to null, right? In Pandas, you have something called a null. Oh, small line itself. Never mind. No idea what. Anyway, so np.none is exactly similar to null in Python, except it is specific to that in your Panda series, right? And just remember, it's from the NumPy library. Now, every time you see an np.none, np.none has a specific data type by itself. If I just do a d type, np.none, what do I get? Oh. Right. So if you see here, sorry?
I think, oh yeah, cool. Go ahead.
Yeah. So if you see here, np.none over here, it's supposed to be a null value, right? And a null doesn't really have a specific data type. It really binds itself to. But an np.none has a float data type, and that is only because floats are essentially the largest consumers of bytes or the largest consumers of memory. So to save as much data as possible, it converts everything into a float, a string, integer, whatever it is. If it can be converted into a float, it would be converted into float to save as much data as possible. And those values that are null values, the reason it's actually taking up a lot of memory is because it's anticipating you to fill those values with a specific number of so it's anticipating you to fill those values with different values, and it's how do I put this? It is anticipating you to fill in those values with the maximum possible value, and the maximum possible is a floating type value, right? And so it is always ready for any move that you're trying to make, and that is exactly why np.none is a floating type value, right? And so if and so I could do things like, so you guys remember the relation operators and addition operators and type broadcasting, right? It returns an entire series with booleans. And so if I do something called sal.isNull, again, it returns me those values where you actually find isNull in those specific columns or rows. So as you can see here, our first 3 values of notes or our first 3 values of benefits was null. And in the same way, benefits, almost the first, 100 values are null. And same way, notes, the first 100 values are null. And so like that, I can pass sal.isNull, which again is a very important helper function. All right, I'm just gonna do a heat map so you guys know what I'm talking about, and you'll learn heat map soon enough.
Yeah, talking about heat map, I think we should move on to the next module.
Okay, yeah. Just gonna pass this in, and hopefully they know what I'm talking about. And
just store the heat map somewhere and then print it, I guess.
Yeah, just do, I think, Matplotlib.inline or something.
All right. Anyways, we're going to come through heat maps with Sanjo. And so I think this is a good place to stop. I'm just going to review everything that I just did very haphazardly. And that is, yes, here. So a Panda series is built on NumPy arrays. A Panda series is essentially a NumPy array with indexing. And so if I were to convert anything into a series, I just do a 1, 2, 3, 4, or a label, just a list or a dictionary. A dictionary would have its keys as an index, its values as a series values, and a list just converts everything into values with an automatic indexing starting from 0, right? To convert anything into a data frame, you just take the same list, pass it into a data frame just like you did in series, or you could pass the NumPy array, or you could pass the series itself, and it will convert everything into a data frame with, again, indexing and a column header. It's important to know that in a Pandas data frame is essentially made up of a bunch of series with a column name. So they're pretty much the same thing. It has some special functions like pd.read.csv, .read.excel, .read any file really. All you have to do is look up the documentation, just like I did much before, pandas.pydata.org, and it gives you a list of functions that could help you in any time in the future, right? And to access values, simply like a 2-dimensional matrix or .lock or .ilock. Again, then you have broadcasting with relational operators, arithmetic operators, and again, you have everything passed down to a simple one-liner. After that, again, broadcasting, you guys, pretty sure you guys know it by now, and .head, .isNull, and we will explore a lot more functions later as we go into the weeks, but I think this is as of what you need, this is important for now, right? And so I'm going to pass it on to Sanjog, who's going to take the visualization aspect for you guys.
All right. Let me just share screen. Give me 1 second. Yeah. The slides are here. Where's my Seaborn? Yep. So, I hope you can see the slides. First thing, I'll ask you to relax after that loads of information that you got. Oh yeah, by the way, this is our man Pratt's dog. He's called Shizzle. Anyway,
He's not called Shizzle, man.
We'll be looking at Matplotlib and Seaborn. So we're not really going to be doing a lot of Matplotlib, more Seaborn, because it's a little more beautiful and it looks a lot better. Although it is built on top of Matplotlib, so we would need some knowledge of Matplotlib before we can hop onto Seaborn. Let me go to my notebook and then we can start. Right, so what is Seaborn? Seaborn is a statistical plotting library, and it's designed to work with the Pandas data frame. So that's why we taught you Pandas data frames before we could hop onto some data visualization. So before we could start anything really, we need to install Seaborn. So by typing the exclamation mark in your notebook, you can give in commands to the command line. So for example, if I want to print my working directory, I just do print working directory. So this is directly from my command line. This has nothing to do with my notebook. So similarly, I'm going to install Seaborn by typing pip install Seaborn. And as you can see, I've already downloaded Seaborn, but for you guys, it might take like 5 seconds. So I'm hoping if you have any problems with installation, please put it up in the chat. All right, so let's import Seaborn. Import Seaborn as SNS, and we'll also import matplotlib.pyplot as PLT. So these SNS and PLTs are like standard ways of importing Matplotlib and Seaborn. So like if you see SNS anywhere, it's probably going to be the Seaborn library. And we use this one command called matplotlib Inline. Now this is notebook specific. This is just to tell the interpreter that we want you to display the graph in the notebook instead of saving it or displaying it in the terminal. So this line is important if you want to be looking at your graphs in the notebook. All right, so Seaborn has a lot of preloaded data sets. We're going to be using one data set called diamonds. So let's just load up the data set. So diamond equals SNS dot. Yeah, another thing is if you've done any object-oriented programming, really, you can quickly notice that SNS or Seaborn is like a huge class. So if you want to access any method inside the class, you just use the dot operator. So load dataset would pretty much be a method inside the Seaborn class, and will provide the name of the dataset, which is called diamonds. Oh no, load dataset, sorry. Load dataset. Yeah, so as Pratt mentioned, you can, this is going to be of type Pandas data frame. So this is why data frames are really important. If you want to visualize, everything is done through data frames. You pass in your data through data frames. You could also do Panda series, but in data frame is the common way to do it. So you can see the type of the data frame, sorry, the type of a diamond is data frame. So before visualizing, we usually quickly just look at what's in the data. So we've got like 9 columns. So today I'll probably pick, we'll visualize the carat of the diamond with the price of the diamond. We can compare, correlate, all that sort of good stuff. Now, a very simple visualization tool is DiscPlot, which helps you visualize the distribution of a column. So let's say we want the distribution of the column carat. Oh, sorry. My bad. So to access the columns, we do diamonds and then index it at carat. So this should work. Oh, it's diamond. Jesus. Yeah. So this plot, I want you to keep in mind that it's just for one column and you're visualizing the distribution of one column. So if you want to see how, let's say, the price is distributed, it's pretty much like this is how, like you can see the majority is in, I don't know, 0.0004 for some reason. So that is the price. And if you want to see the depth, I don't even know what depth of a diamond means, but this is what depth means. But as you can see, like this doesn't really give you any meaning, right? So you want to compare like the price of the diamond, compare it with the carats of the diamond. So for this, we're going to be using something called line plot. So line plot helps you visualize one column with another column. So line plot is also pretty easy. You just give the x-axis, let's say carat, and the y-axis, which is price, let's say price. And you obviously have to pass in the data as a data frame, which is diamond. So sorry, was that a question? I
don't think that was a question. Just go ahead.
All right. So you can see that this gives you some more insight into the data, right? You can see as the carats increase, the price increases sort of. So this is more explanatory, and visualization is really how you communicate your data to like managers or other people who really don't know like the coding aspect. So you can see like anybody can visualize and interpret this graph saying, okay, as carat increases, my price increases. It's pretty self-explanatory. And oh yeah, another thing is if you want the Seaborn documentation is really going to help you like a lot. Like it's really helpful. So I want you to just type Seaborn and go to this link. It's called seaborn.pydata.org. I'll just put it up in the chat. Wait, just a second. Oh no. Can someone? Okay, I got it. Yeah, so I put it up in the chat. Now, yeah, this website is really cool. It shows you everything you need to know in Seaborn. So if you go to gallery, you have the different types of plot that Seaborn offers. For example, all right, let's look at scatterplot. So now you can see that this is how scatterplot looks, and here's the source code for scatterplot. So we could literally just copy paste this code and it would run on our data set. They've used diamonds as well. That is a good. All right, so let's do scatterplot. So firstly, I'll just do a simple scatterplot without any, like crazy arguments and stuff. So scatterplot also helps you visualize how the data is scattered, like the spread of the of data. And this is also a 2D visualization technique. So I'm going to do the same thing, caret and price with my data as diamond. All right, so you can see, okay, that looks a little weird. Can't really interpret what the hell is going on. But so let's make it a little better. All right, so like I said, Matplotlib is important because Seaborn is built on top of Matplotlib. So this is where I'll illustrate how Matplotlib is going to help. So for Matplotlib, it's generally used to set the axes, set the figure for the graph. And Seaborn is just putting in values to the graph, like beautifying it and giving it a good display, right? So let's first make the figure of the graph. So we use figure, and this axis. We say PLT. Remember, PLT is how we imported Matplotlib. .subplots, that's a method in Matplotlib. And let's say we set the size of, fig size. Let's set the size of the figure to be, I don't know, like 10, 10. So this is the size of the graph we want. So this is done using Matplotlib. All right, and then let's do the scatterplot. SNS.scatterplot caret. This is the same thing, really. Price, and then we've got. Let's say we want to add some hue. So we want to like change up colors for different numbers, for different values. We want to change different. We want to add different colors. So that's done by using hue. And clarity is just one way of doing it. You can literally do. So I'm using clarity as this column. You could use color. You could use depth. You can use table. Anything is fine. But basically, what it tells Seaborn to do is use clarity to set the hue for different values. So for different values of clarity, there'll be different values of different colors. All right. So we also have to set a hue order, which gives you like it's pretty self-explanatory. It's hue order. I'm going to say clarity ranking. And yeah, just data equals diamond. Whoa, there is an error. Hang on. Oh yeah, wait, we'll just remove this for now. I haven't defined what clarity ranking is, sorry. Right, okay, so that looks a little better. Like you can see here that the color is dependent on the value of clarity. For example, like let me change that to depth. So depth, this is going to be a lot of colors, I think. Yeah, so that really doesn't help us. So clarity was a better option. So let me go back to clarity real quick. Clarity. Yeah, so you've got clarity. This is just like a little better. to interpret and understand. Obviously now, because the data set isn't clear for us, we really don't know, like it's not as transparent, but once the data set is clear, once you know what data you're working with, these arguments are really going to help you, communicate your data better. Yeah, now, then again, like I said, Seaborn is built on top of Matplotlib. So we're going to be, sorry?
Oh, string converter, string term. Sorry.
Okay, so Seaborn is built on top of Matplotlib. So I mentioned earlier that Matplotlib controls the graph size, the axes, and everything. So if you want to, so now you can see like there's pretty much nothing in the graph. So if I want to set a label for my x-axis, I just call plt.x-axis and I don't know, label it caret in caps, and plt.y label price. So that should work. Seaborn actually does it by default, like depending on your x value and your y value, it sets the axis names. But if you want to change it to something unique or user defined, you have to use Matplotlib's PLT. And if you want to add a title to your graph, give it some more meaning, you can use the method subtitle. And you can say, all right, this is my title. And you can set a font size, font size equals, let's say 11 or something. So yeah, you've got the title there, you've got the X label there, and the Y label there and the X label there, and you've got the graph. So that's all well and good, but another really important data science plotting is called a heat map. Now, Pratyush was getting onto it, but yeah. So a heat map essentially measures how two columns are correlated with each other. So if you could see, this sort of tells us that the price and caret were sort of positively related. What that means is if the number of carets increases, the price increases. So you could do this, but if you want to find the correlation between all the columns in the data set, you call something called, so if you have correlation equals, so you call the data set, which is diamond dot core. So dot core, this returns a matrix specifying how exactly our data set, and I mean the columns in the data set are correlated. So you've got caret and caret. Obviously, they're correlated with a factor of 1 because they're the same column. You've got depth and caret, which are not really correlated, slightly correlated. But as you can see, price and caret, they're highly correlated with 0.92. Anything above 0.8 is, we say it as highly correlated, and anything below 0.2 is barely correlated. So let's visualize this correlation using a heat map. So heat map, and we pass in the correlation matrix. Boom. So you can see it also gives you a key and a heat map. So you can see the diagonal will always be highly correlated because it always means correlation with the same column. So caret and caret, you've got depth and depth, you've got table and table. So they're obviously highly correlated with each other because they are the same column. And you can see that depth and caret is pretty low correlation, but you can see price and caret are pretty highly correlated because that makes sense, right? So this is pretty apparent, like because we've got caret and price, and we know that caret and prices are highly correlated, and the data is confirming that. So this is how you explain or communicate with data by saying price and caret are correlated using data pretty much. So that is pretty much it for visualization. It's just like a gentle introduction, but it should like equip you with skills to do any sort of visualization you want. For example, this looks pretty beautiful. Just look at the code here. You can see that they're setting up the axis using Matplotlib. They're just generating a random, which is NumPy again, which are a random matrix. And they're pretty much plotting using KD plot. So this is another method. I suggest you go through this Seaborn documentation, see what plots are used for what. Now, a good way to tell what plot is used for, so you need to choose the plot as well, right? So if you just want the distribution, you go with dist plot. So that stands for distribution plot, just one column, not really explanatory. If you wanted to find the correlation or sort of how two columns are related, you go with the line plot. You pass in two arguments, which are both columns in your data frame, and you pass in the data frame. If you want to see how your data points are scattered, so scatterplot plots each single point in the data set, so you can see how well they're scattered. You can see there's sort of a correlation between price and caret here as well, because it has a positive slope. And yeah, you can just beautify scatterplot using like multiple arguments. And this is also found in the Seaborn library. And yeah, correlation for finding out how two columns are correlated. This is pretty important when you're doing like data analysis, for example. Like if you have a data set for murder, let's say, you can find places where murder rates are high, where murder rates are low. So it's a really good visualization technique for exploratory analysis. And yeah, that's pretty much it.
Just to let you know, this is the weekly workshops for the next 6 to 8 weeks. And we hope you can be part of every single workshop from now on, because now you know the basics. Now, from here on, it's always the fun stuff and nothing else. We're going to make some complex models. We're going to do some really exciting stuff. Next week would be about supervised versus unsupervised learning, some train test split, and we'll actually work on some real life data sets like the Titanic data set, which is pretty fun to work on.